In physics, motion is a change in position of an object with respect to time and its reference point. Motion is typically described in terms of displacement, direction, velocity, acceleration, and time. Motion is observed by attaching a frame of reference to a body and measuring its change in position relative to that frame. If the position of a body is not changing with the time with respect to a given frame of reference, the body is said to be at rest, motionless, immobile, stationary, or to have constant, time-invariant, position. An object's motion cannot change unless it is acted upon by a force, as described by Newton's first law. Momentum is a quantity which is used for measuring motion of an object. An object's momentum is directly related to the object's mass and velocity, and the total momentum of all objects. In an isolated system, one not affected by external forces, does not change with time, as described by the law of conservation of momentum. The study of motion deals with 1. The study of motion of solids, mechanics. 2. Study of motion of fluids, fluid mechanics. As there is no absolute frame of reference, absolute motion cannot be determined. Thus, everything in the universe can be considered to be moving. 2021. More generally, the term motion signifies a continuous change in the configuration of a physical system. For example, one can talk about motion of a wave, or a quantum particle, or any other field, where the configuration consists of probabilities of occupying specific positions. Laws of motion. In physics, motion in the universe is described through two sets of apparently contradictory laws of mechanics. Motions of all large-scale and familiar objects in the universe, such as projectiles, planets, cells, and humans, are described by classical mechanics. Whereas the motion of very small atomic and subatomic objects is described by quantum mechanics. Classical mechanics is used for describing the motion of macroscopic objects, from projectiles to parts of machinery, as well as astronomical objects, such as spacecraft, planets, stars, and galaxies. It produces very accurate results within these domains, and is one of the oldest and largest subjects in science, engineering, and technology. Classical mechanics is fundamentally based on Newton's laws of motion. These laws describe the relationship between the forces acting on a body and the motion of that body. They were first compiled by Sir Isaac Newton in his work Philosophiae Naturalis Principia Mathematica, first published on July 5, 1687. His three laws are: 1. In the absence of a net external force, a body either is at rest or moves with constant velocity. 2. The net external force on a body is equal to the mass of that body times its acceleration, F equals m. Alternatively, the acceleration is directly proportional to the force causing it, and inversely proportional to the mass. 3. Whenever one body exerts a force F onto a second body, the second body exerts the force F on the first body. F and F are equal in magnitude, and opposite in sense. Newton's three laws of motion, along with his Newton's law of motion, which were the first to accurately provide a mathematical model for understanding orbiting bodies in outer space. This explanation unified the motion of celestial bodies and motion of objects on Earth. Classical mechanics was later further enhanced by Albert Einstein's special relativity and general relativity. Motion of objects with a high velocity, approaching the speed of light. General relativity is employed to handle gravitational motion at a deeper level. Quantum mechanics. Quantum mechanics is a set of principles describing physical reality at the atomic level of matter, molecules, and atoms, and the subatomic, electrons, protons, and even smaller particles. These descriptions include the simultaneous wave-like and particle-like behavior of both matter and radiation energy. This is described in the wave-particle duality. In classical mechanics, accurate measurements and predictions of the state of objects can be calculated, such as location and velocity. In the quantum mechanics, due to the Heisenberg uncertainty principle, the complete state of a subatomic particle, such as its location and velocity, cannot be simultaneously determined. In addition to describing the motion of atomic-level phenomena, quantum mechanics is useful in understanding some large-scale phenomenon such as superfluidity, superconductivity, and biological systems, including the function of smell receptors, and the structures of proteins. List of imperceptible human motions. Humans, like all known things in their universe, are in constant motion. 8-9 However, aside from obvious movements of the various external body parts and locomotion, humans are in motion in a variety of ways which are more difficult to perceive. Many of these imperceptible motions are only perceivable with the help of special tools and careful observation. The larger scales of imperceptible motions are difficult for humans to perceive for two reasons. 1. Newton's laws of motion, particularly inertia, which prevent humans from feeling motions of the mass to which they are connected, and 2. The lack of an obvious frame of reference which would allow individuals to easily see that they are moving. The smaller scales of these motions are too small for humans to sense. Universe. Space-time, the fabric of the universe, is actually expanding. Essentially, everything in the universe is stretching like a rubber band. This motion is the most obscure, as it is not physical motion as such, but rather a change in the very nature of the universe. The primary source of verification of this expansion was provided by Edwin Hubble, who demonstrated that all galaxies and distant astronomical objects were moving away from us. Hubble's law is predicted by a universal expansion. Galaxy. The Milky Way galaxy is moving through space. Many astronomers believe the Milky Way is moving at approximately 600 km/s relative to the observed locations of other nearby galaxies. Another reference frame is provided by the cosmic microwave background. This frame of reference indicates that the Milky Way is moving at around 552 km/s. Sun. The Milky Way is rotating around its dense galactic center, thus the Sun is moving in a circle within the galaxy's gravity. Away from the central bulge or outer rim, the typical stellar velocity is between 210 and 240 km/s, about 500,000 mph. Solar System. All planets and their moons move with the Sun, thus the solar system is moving. Earth. The Earth is rotating, or spinning around its axis. This is evidenced by day and night. At the equator the Earth has an eastward velocity of 0.4651 km/s, 1040 miles/h. The Earth is orbiting around the Sun, in an orbital revolution. A complete orbit around the Sun takes 1 year, or about 365 days. It averages a speed of about 30 km/s, 67,000 miles/h. Continents. The theory of plate tectonics tells us that the continents are drifting on convection currents within the mantle, causing them to move across the surface of the planet at the slow speed of approximately 1 inch, 2.54 centimeters, per year. However, the velocities of plates range widely. The fastest moving plates are the oceanic plates, with the Cocos plate advancing at a rate of 75 mm/yr, 3.0 in/yr, and the Pacific plate moving 50 to 69 mm/yr, 2.1-2.7 in/yr. At the other extreme, the slowest moving plate is the Eurasian plate, progressing at a typical rate of about 21 mm/yr, 0.8 in/yr. Internal body. The human heart is constantly contracting to move blood throughout the body. Through larger veins and arteries in the body, blood has been found to travel at approximately 0.33 m/s. Though considerable variation exists, and peak flows in the venae cava have been found between 0.1 m/s and 0.45 m/s. The smooth muscles of hollow internal organs are moving. The most familiar would be peristalsis, which is where digested food is forced throughout the digestive tract. Though different foods travel through the body at rates, an average speed through the human small intestine is 2.16 m/h, 0.036 m/s. Typically some sound is audible at any given moment. When the vibration of these sound waves reaches the eardrum, it moves in response, and allows the sense of hearing. The human lymphatic system is constantly moving excess fluids, lipids, and immune system-related products around the body. The lymph fluid has been found to move through a lymph capillary of the skin at approximately 0.000097 m/s. Cells. The cells of the human body have many structures which move throughout them. Cytoplasmic streaming is a way which cells move molecular substances throughout the cytoplasm. Various motor proteins work as molecular motors within a cell and move along the surface of various cellular substrates such as microtubules. Motor proteins are typically powered by the hydrolysis of adenosine triphosphate, ATP, and convert chemical energy into mechanical work. Vesicles propelled by motor proteins have been found to have a velocity of approximately 0.00000152 m/s. Particles. According to the laws of thermodynamics, all particles of matter are in constant random motion as long as the temperature is above absolute zero. Thus the molecules and atoms which make up the human body are vibrating, colliding, and moving. This motion can be detected as temperature. Higher temperatures, which represent greater kinetic energy in the particles, feel warm to humans, whom sense the thermal energy transferring from the object being touched to their nerves. Similarly, when lower temperature objects are touched, the senses perceive the transfer of heat away from the body, as feeling cold. Subatomic particles. Within each atom, electrons exist in an area around the nucleus. This area is called the electron cloud. According to Bohr's model of the atom, electrons have a high velocity, and the larger the nucleus they are orbiting, the faster they would need to move. If electrons move about the electron cloud in strict paths the same way planets orbit the sun, then electrons would be required to do so at speeds which far exceed the speed of light. However, there is no reason that one must confine oneself to the strict conceptualization that electrons move in paths the same way macroscopic objects do. Rather, one can conceptualize electrons to be particles that capriciously exist within the bounds of the electron cloud. Inside the atomic nucleus, the protons and neutrons are also probably moving around due to the electrical repulsion of the protons and the presence of angular momentum of both particles. Light propagates at 299,792,458 m/s, often approximated as 300,000 km per second or 186,000 miles per second. The speed of light, or c, is the speed of all massless particles and associated fields in a vacuum, and it is the upper limit on the speed at which energy, matter, and information can travel. Types of motion. Simple harmonic motion, e.g., that of a pendulum. Unharmonic motion. Periodic motion. Rectilinear motion, motion which follows a straight linear path, and whose displacement is exactly the same as its trajectory. Reciprocal motion, e.g. vibration. Brownian motion, i.e. the random movement of particles. Circular motion, e.g. the orbits of planets. Rotary motion, a motion about a fixed point, e.g. Ferris wheel. Curvilinear motion, it is defined as the motion along a curved path that may be planar or in 3 dimensions. Rotational motion. Rolling motion, as of the wheel of a bicycle. Oscillation. Combination motions, combination of 2 or more above listed motions. Projectile motion, uniform horizontal motion plus vertical accelerated motion.